So in transaction, there are hundreds of users using the same database concurrently, means simultaneously. So whatever the condition that occurs, it should necessary to cancel those conditions during the transactions. So the transaction which is submitted by the various user is executed concurrently. So multi-user system means multiple users are accessing the same database at the same time. Hello everyone, welcome to another session of DBMS. I am Soundarya from CS Department, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. So today the last unit, Query Processing Transaction Management. So in that we have transaction. Transaction is nothing but we perform in our day-to-day life. While if you want to take money, we insert an ATM card. First we insert and enter a PIN code and then withdraw some money. So in the same way, how the transaction takes place in our day-to-day life. So the concept of the transaction provides a mechanism for describing the logical unit of the database processing. So the concept of the transaction, it provides a mechanism for describing the logical unit, maybe inserting, deleting, updating of the database processing. So the transaction processing systems are the system with a large database and hundreds of the concurrent users that are executing the database transaction. So in transaction, there are hundreds of users using the same database concurrently, means simultaneously. The same data which is used by the multiple user to perform some operations. So that is concurrent users, where the hundreds of users using the same data simultaneously and executing the database transaction. While they are executing the database transactions. So transaction which is used to represent a logical unit of the database processing that must be completed in its entirety to ensure correctness. So which is used to represent the logical unit of the database and that must be completely in its entirety to ensure the correctness of the database. So example where we see the concurrent user for the transaction. So example for the transaction is railway reservation, where the multiple users are using the railway reservation a website to reserve their books. So example for the system, you can see railway, airlines, booking. So that is an example. Banking. So even in banking, there are so many people are withdrawing money and depositing money. We can see that. Credit card processing. So that's an example for transaction. Stock markets, supermarkets, checkout, etc. So these are all the example for transaction. Next is single user and multi-user system. In single user system means only one user using the system. So multi-user system means multiple users are accessing the same database at the same time. If at most only one user at a time. So single user means only one user at a time can use the system. Single user DBMS are restricted to some microcomputer system. So single user DBMS are restricted to use microcomputer system. So multiple user system. If many users can use the system and hence access the database. So multiple users means multiple users can use the system and they can access the database. Concurrency means simultaneously they can make use of the system. Most other DBMS are multi-users. So most of the DBMS are multi-users. Example for multi-user system is an airline reservation system is used by hundreds of travel agent and reservation clerk concurrently. So in airline reservation, that was used by the system where hundreds of travel agencies are making use of that and the reservation clerk are also using concurrently. Means which is used by the travel agent and the airline clerk. Means it performing simultaneously, means concurrently. Systems in bank, insurance agencies, stock exchanges, supermarkets, and also operated on by many users who submitted transaction concurrently to the system. Now, the difference between single user database system and the multi-user database system. As I already told you, single user database system means which is accessed by only one person at a time. A DBMS is a single user if at most only one user at a time can use the system. Here only one user at a time can use the system. In multi-user system, if many or multi-user can use the system and hence access the database concurrently. In multi-user system, then multiple people are using the system and they can access the database concurrently. Single user DBMS are mostly restricted to use personal computer system. Single user DBMS are mostly restricted to the personal computers, that is personal PC computers, and most DBMS are multi-users like database or airline reservation system and in banking database system. Single user databases do not have multi-programming. So single user means that is restricted to only one person and they do not have a multi-programming. A single CPU can have execute at most one process at a time. A single CPU can only execute only one process at a time. Multi-users can access the database and use the computer system simultaneously because of the concept of multi-programming. In multi-user system, they can access the database and can use concurrently, which can be accessed by multiple users. Next is transaction read and write operation. So in transaction read is used to read item. It reads the item that is named X. So it must be named. The read item should be named X into the program variable. So here it reads the database item that must be named X into the programming variable. In write operation, writes the value of the program variable X into the database item named X. Executing the read item X command include the following steps. So how to execute the read item? It includes 3 steps. First we need to find out and then copying the variable and copying the buffer variable to the programming variable. First one is, first you need to find the address of the disk block that contain the item X. So first you need to contain the disk block which contain the item X. Then copy that disk block into the buffer in the main memory. If that disk block is not already in the same memory buffer, so that's already in the disk main memory. Next, copy item X from that buffer to the program variable named X. Now copying that item X from the buffer to the program variable named. That is all about how to execute read program. Next is write. So executing the write item command includes the following steps. There are few steps how to execute the write item. So first you need to find the address of the disk block that contains item X. Next, copying that disk block into the buffer in the main memory. If that disk block is not already in the same main memory buffer. Next, copy the item X from the program variable named X into its correct location in the buffer. Next, copying that item from the buffer program variable that must be named X into the correct location. So where you want to locate in the buffer. Next, you need to update. Store the updated block from the buffer back to the disk either immediately, you can update it immediately or some later point in that time. Next, concurrency control and recovery mechanism are mainly concerned with the database access command in the transaction. So here the data is a multiple user system, the data is performing concurrently and recovery of the mechanism are mainly concerned with the database. Next is transactions submitted by the various users. Many execute concurrency and many access and update the same database item. So the transaction which is submitted by the various user is executed concurrently. So simultaneously whatever the data which is sent by the users are executing simultaneously and can access and update the same database item, where you can access and update the same database item. If the concurrent execution is uncontrolled, suppose if the concurrent execution is not controlled, it may lead to the problem such as inconsistent database. It leads to the problem that is the data is not consistent. Next is need of the concurrency control. So why do we need to control the concurrency? The thing is that simultaneous execution. So the data is used by the multiple user which are performing concurrently, and the thing is which is simultaneously the data is executing. That is performance should be done in an interleaved manner. So the data which is sent by the multiple user which are coming simultaneously, the performance should be done in an interleaved manner. Means it should not affect the other operation while performing. And no operation should affect the other execution operation. So whatever the performance we are doing, it should not affect the other. Thus maintaining the consistency of the database. So that's how we need to maintain the consistency of the database. Thus by making the concurrent execution of the transaction operation, there occur several challenging problems that need to be solved. So what are the problems that occur while performing concurrent execution? So we should be performed in an interleaved manner without affecting the other operation. So there are several challenges occurs while performing, so that has to be solved. So while performing concurrent execution, there are two problems occurs. The following problem occurred with the concurrent execution of the operation: lost update problems, and next is dirty read problem. So the first one is lost update problem. So the name itself says that where it lost its update while performing some operation. Here the problem occur when two different database transactions, that is read or write operation. The problem occur when two different database transactions performing the read or write operation on the same database item. The read and write operation were performing on the same database transaction. It performing on the same database item in an interleaved manner, means without affecting the other operation. Concurrent execution means which is performing simultaneously, that makes the value of the item incorrect, and while performing these operations that make the value incorrect, hence making the database inconsistency. While performing a concurrent operation that makes the value incorrect, and that leads to lost update problem. So the example for that is, so here we have given diagram. So T1, T2, T3 represent the time, and Tx is the transaction Tx and the Ty is the transaction Y. So in the first step, it reads the value of A. The value of A is $300. So first it reads the value of A at the time T1, and at the time T2, the value of A will be deducted, means 300 minus 50, so which leads to 250. At the time T3, it reads the value of A again, that is 300. At the time T4, it reads the value of A, that the value of A will be get added, that is 300 plus 100, that is 400. And at the time T4, it will do nothing. Then at the time T6, it reads the value of A, then it will get updated. But at the value of T7, it also value of the A will be updated, that is Ty will be get updated, but the value of Ty is not updated. It say has 300 itself, so it lost its update, so only it is called lost update problem. Next is dirty read problem. In dirty read problem occurs when one transaction updates an item of the database and somehow the transaction fails. So though it updates, the transaction fails. And before the data gets rolled back, the updated database item is accessed by the another transaction. So before the data get rolled back and the updated database item, it accessed by another transaction. This comes a read-write conflict between the both. So example, consider the two transactions, one is Tx and another one is Ty in the below diagram performing read-write operation and the available balance of the account. So let us see the example for dirty read problem. So T1, T2 all represent time, and Tx the transaction X and the transaction Y. Here at the time T1, it reads the value of A. At the time T2, it deduces the value 300 minus 50, that is 250. At the time T3, it updates the value, and again at the time T4, it reads the value of A. But due to some server problem, server down, the data get never updated. So that leads to server down or roll back. That is dirty read problem. Next is types of failure. In types of failure, the first one is computer failure. So computer failure may be because of the hardware, software or the network failure. So the hardware, software or the network error that we face in our systems occurred in the computer system during the transaction execution. So while performing some transaction execution, because of the hardware or software or the network error that is occurred, that is system failure. Next is transaction or the system error. So in transaction or system error, transaction failure may also occur because of the erroneous parameters. So whatever the erroneous parameters we have, so values of the logical programming error means update, select and update, insert. The user may interrupt a transaction during its execution. So while performing some transaction, the user may interrupt the execution. So that is leads to transaction or system error. Next is local error or exception condition detected by the transaction. So what are the error and the condition that is detected by the transaction? During the transaction execution, certain condition may occur that necessitate the cancellation of the transaction. So whatever the condition that occurs, it should necessary to cancel those conditions during the transactions. Next is concurrency control enforcement. The concurrency control method may decide to abort the transaction to be restarted later because it violates the serializability or because the several transactions are in the state of deadlocks. So in concurrency control enforcement, the method may decide to abort the transaction to be restarted later. It aborted and then restarted later because of the violent serializability or because of the several transactions that is performing concurrently or in the state of deadlocks or maybe in the state of deadlocks. Next is disk failures. In disk failures, some disk block may lose their data because of the read or write malfunction or because of the disk read or write head crash. So some disk block may lose their data because of the read or write head crash. Next is physical problem or catastrophes. So in this, these refer to an endless list of the problem. So whatever the endless list of the problem that occurred while performing transaction that include power, maybe power supply or air conditioning failure, fire, theft and stubborn edge, overwriting disk or tapes by mistakes and mounting of the wrong tape by the operator. So these are the types of failures occur while performing transaction. Next is transaction states. So what are the states that we have? The first is active state, partially committed, terminated, aborted and failed. So if the active state is the first state of the transaction, so it performs some basic operation in active state where the data are not stored. Transaction is executing. So in active state where it is getting activated to perform some operation. Active state is the first state to perform some basic operation. So where it getting activated to perform some insert, delete or update operation. So that is the transaction is executing. It's in the state of executing. Next is failed. So transaction failed to completely successful. Suppose if the transaction failed to completely successful, it may be fail or it will be completely successful. Next is abort. So change made by the transaction are cancelled or it get rolled back and it bring back to its consistent state. Suppose the changes, whatever the changes that is made by the transaction are get cancelled or it get cancelled, rolled back and it bring back to its consistent state or the previous state. Partially committed. So final statement or the transaction is partially committed. So whatever the final statement of the transaction is executing, but the data are not saved. So committed. So in commit state, the data are saved and it executed successfully. The transaction completes its execution successfully. Next is terminated. Transaction is finished. Terminated is nothing but where the transaction is completely finished. The last concept is desirable or acid properties of transaction. Acid means atomicity, consistency, isolation and durability. So in atomicity, the transaction is an atomic unit of processing. So it's an atomic unit of processing. It may be either performed in its entirely or not performing at all. Next is consistency preservation. In that we have the transaction is consistent, means whatever the operation that is performing, it should be consistent and preserving. If its complete execution take the database from one consistent state to another and it taking the database from one consistent state to another. Isolation, the transaction should appear as it though it is being executed in isolation from other transaction. That is, the execution of the transaction should not be inferred with by other transaction execution concurrently. So it should not affect the other transaction while performing some operations. Next is durability or permanency. So the changes applied to the database by the committed transaction. So whatever the changes that we apply to the database should be committed to the transactions. Thank you.